Hi, in this video, we'll be looking at the inverse of a matrix, how to find the inverse of a matrix. In order to be able to find the inverse of a matrix, we must be able to find the determinant of a matrix. We must be able to find the cofactors of a matrix. We must be able to transpose a matrix. And obviously, we must be able to find the adjoint of said matrix. If we're able to do all these things, then definitely we can find the inverse of a matrix. So remember, we've looked at concepts. We looked at how to find the determinant of a matrix in previous videos. We've looked at how to find the adjoint of a matrix. By virtue of how to find the adjoint of the matrix, we've looked at how to find the cofactors and also how to find the transpose of a matrix. Now, a matrix is said to have no inverse if it is singular. If a matrix is singular in nature, singular. So what does it mean if a matrix is singular? It means after finding the determinant of a matrix, the value you are having is resulting into zero. If the value of the determinant of a matrix is zero, then definitely we say such matrix as singular. Of course, we didn't talk about the singular type of matrix when we're talking about the types of matrix, but this is another type that we should be familiar with. Now we have the singular matrix and then we have the non-singular matrix. For singular matrix, after finding the determinant, it will be equal to zero. For non-singular matrix, after finding the determinant, it won't be equal to zero. So before you can find the inverse of a matrix, you must make sure that the matrix, first of all, is not singular, and secondly, it must be a square matrix. So if it is a square matrix and it is not singular, then definitely you can find the inverse of said matrix. So let's try and look at an example. So we start with a 2 by 2 matrix. So let's say how to find the inverse of a 2 by 2 matrix. Now you should know that the inverse of a matrix, let's say we're given matrix A, is given as 1 divided by the determinant of such matrix multiplied by the adjoint of the matrix. So if we want to find the inverse of any matrix, then this is the formula that we want to use. So 1 divided by the determinant times the adjoint of the matrix. Okay, so let's take our first example and then let's see how we're able to simplify that and also find its inverse. So 2, 4, and then 3, negative 2. Okay, so we're told that this is the matrix A. So this is matrix A, and then we're asked to find A inverse. So A inverse would be, so what do we do? So first of all, we find the determinant of this matrix. To find the determinant of the 2 by 2 matrix, what do we do? So we just, A is equal to put a square bracket, so 2, 3, 4, and negative 2. Okay, so and then multiply the leading diagonal, that is 2 times negative 2, so we have negative 4. Okay, subtract it with 4 times 3 is 12. So 4 times 3 is 12, so we have this. So and finally minus 4 minus 12, so that's negative 16. So you can see that this matrix is non-singular. So if it is non-singular, then definitely it has an inverse. Okay, so we've gotten the determinant to be negative 16. Now it's time to find the adjoint of this matrix. So to find the adjoint of the matrix, so we simply find the cofactors first. So cofactor of A would be, so again, if you've not forgotten the sign, this has positive, negative, negative, and positive. So the minor of the first element here is negative 2. So we have negative 2 here because negative 2 times positive 1 is still negative 2. The minor of this is 4. So but since there's a negative value here, so it becomes negative 4. And then the minor of 4 is 3. So again, there's a negative sign here. So it has negative 3. And then the minor of this is 2. Okay, so which has a positive value. So we have this. So after finding the cofactor, we simply transpose this matrix. So transposing this matrix, we have so here we have negative 2, negative 4, and then negative 3 and 2. So this is my transpose matrix. So this transpose matrix is the adjoint of A. So I've gotten the adjoint of my matrix. Of course, we did talk about the shortcuts. You just swap the matrix, swap the leading diagonal. So you swap the leading diagonal, and then you leave the backward diagonal constant, but negate them. So you can see we're still arriving at the same thing, even if we use the shortcut. even though we use the shortcut. Okay, so now it's time to apply our formula to find the inverse of our matrix. So A inverse would be equal to 1 over, so my determinant, so there's negative sign here, so minus 16, then we have minus 2, minus 3, minus 4, and 2. So just like we did when we were taking the scalar multiplication of matrix, so I want to multiply each of these elements by negative 1 over 16. So here, my first element here, so minus 2 times this, so 3 in 16 is 8, negative divided by negative times negative, that's positive. So I'll be having 1 over 8 as the first member. So 3 over 16, this becomes 3 over 16 positive, because negative and negative, by the time you multiply them together, becomes positive. So, and then for the below, this is, so I'll be having 1 over 4, and for this one, I'll be having minus 1 over 8. So this is my, what's it called? This is my inverse, or this is the inverse of matrix. Okay, so let's look at how to find the inverse of a 3 by 3 matrix, a 3 by 3 matrix. So what if we're given a 3 by 3 matrix? How do we find its inverse? So let's say we're given matrix A to be equal to 1, 0, 5, 2, 1, 6, 3, 4, and 0. Okay, so we want to find the determinant first. So you always want to look for the determinants, because once you can find the determinants, you know whether it is a singular matrix or not. Because if it is a singular matrix, then definitely it has no inverse. So that's the first thing you always want to do. Now, in finding the determinant of A, so A, again, we just multiply the elements in the first row, one of them, or one each individually, by their minus and the place value. So of course, by now you should know that for determinants, we assign a sign, plus, minus, and then plus for the first row alone. And then what do we do? So take 1, so then multiply it. So after taking this one, so strike out this, I'm left with 1, 0, 6, 4. So 1 times 0 is 0. 0 minus 6 times 4. Okay, so 1 times 0 is 0. So 6 times 4, that's 24. So that's 24. Then this is minus, so take the next number, this is 0. Okay, in the bracket of, again, do the same thing, strike out this, I'm left with 2063. So 2 times 0 is 0. 3 times 6 is 18. So 0 minus 18. This is what we have. Then lastly, the sign here is positive. So plus, what do we have? 5. Okay, put the number here. Again, strike out this. So 2 times 4, 8. Minus 3 times 1 is 3. Okay, so simplify this. 0 minus 24 is minus 24 times 1. So that's minus 24. 0 times everything here will be 0. 8 minus 3 is 8 minus 3. So that's 5. And 5 times 5, so that's 25 plus. So our answer, or determinant of A, will simply be 1. So determinant of A would simply be 1. So I'm going to clear this place up so we can have space to write other things or to do other things. Yeah, that we need. Remember, we need determinants. We also need the adjoints of this matrix so we can compute it into the formula and find the inverse. So determinant of A is equal to 1. So now let's find the adjoint of A. Before we can find adjoints, I need to find cofactors first. So cofactors of A first will be equal to, so I can just draw my place value sign at the top right corner here. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so let's just use this as a guide. And then so what do we do? For the cofactors of this, we're just looking for the minor now. We're not multiplying with anything. Just the minor and then the place value. So that's this. So strike out the minor of the first element here. Strike out this. So we have 1 times 0, which is 0. 0 minus 24, so is minus 24 times positive 1. So this is negative 24. It's 24. Okay, so we know the second one. So 0, strike out this. I'm left with 2, 6, 3, and 0. So 2 times 0, again, that's 0. 6 times 3, that's 18, isn't it? Okay, so 18 times negative 1, so, or that's minus negative 18. So you have to be careful about the sign. So 2 times 0, 0. 6 times 3, 18. So 0 minus 18, that's negative 18, times negative 1, so that's 18. So, okay. All right, so moving on. 5, strike this, and 2, 1, 3, 4. So 2 times 4 is 8. 3 times 1 is 3, so 8 minus 3, that's 5. So the sign here is positive, so just write positive 5. Okay, moving on to the second one. So strike this, so I'm left with 0, 5, 4, 0. 0 times 0, 0. 4 times 5, 20. 0 minus 20, minus 20. Minus 20 times negative 1, so that's plus 20. So I just write my 20 here. Okay, moving on to this, strike the middle column. So we have 1, 5, 3, and 0. So 1 times 0, that's 0. 0 minus 15 is minus 15. Minus 15 times positive 1 is still negative 15. So write your negative 15 here. Okay. Moving on to 6 is part. Okay. So strike this. So I'm left 1, 0, 3, 4. So 1 times 4, 4. Okay. And then 4 minus 0 is 4 times negative 1. So that's negative 4. Okay. All right. So last row now. Strike out this. So I'm left with 0, 5, 1, and 6. So 0 times 6 is 0. 0 minus 5 so times plus 1. So that will be negative 5. Okay. Now moving on to this. So strike this. I'm left with 1, 5, 2, and 6. So 1 times 6 is 6. 2 times 5, 10. 6 minus 10 as negative 4. Negative 4 times negative 1. So that's positive 4. So I write my positive 4 here. And lastly, this one, strike this. So yeah, 1 times 1, 1. 2 times 0, 0. So 1 minus 0 is 0. So 1 minus 0 is 1 rather. So times positive 1. So we have 1. Yeah, so this is my cofactor. So after finding the cofactor of this matrix, then the next thing to do is to transpose this matrix. So transposing this. So cofactor of A transpose would now be, so we're just interchanging the rows and columns. So this becomes minus 24, 18, 5, 20, minus 15, negative 4, minus 5, 4, and 1. So after transposing it, then this transpose matrix will now be the adjoint of A. So now that we've gotten the adjoint, we've gotten the determinant, then we can now find the inverse. Remember, A inverse will simply be equal to 1 over the determinant multiply with the adjoint of matrix A. So what's my determinant? So that's 1 over 1. Dot what's my adjoint of A? So minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4, and 1. So this is the inverse of my matrix A. All right, so this is all we have for the sake of this video. Remember, in order to find the inverse of a matrix, 2 conditions must be satisfied. First of all, it has to be a square matrix. Second of all, the matrix must not be singular. If it is a singular matrix, then the determinant here will be equal to 0, and anything divided by 0 is undefined, has no value. So hence, if you want to find the inverse of the matrix, those 2 conditions must be satisfied. And if you want to be familiar, if you want to know how to find the inverse of the matrix, then you must know how to find its cofactor, you must know how to find its minor, you must know how to find its transpose, the transpose of said matrix. You must know how to find the determinant of a matrix. All these things, we've done it in previous videos. Just search through the playlist and then you find the videos that's been released on it. So thank you for watching. Do well to like, share, and subscribe to the channel. Also, drop if there's any questions I have not treated that you feel we need to treat during the course of this video, do well to drop it in the suggestion box and then we'll attend to it. Thank you for watching. Stay blessed and bye-bye.